Today we learn one important topics. This topic shows that let Xt be a matrix space. Xt be a matrix space. Then Y be a set and Y be a set, and assume that phi x to y be an bijection. Assume that phi x to y be an bijection. Phi x to y be a bijection. Then we can transfer. Or transport the matrix or transport the matrix on x to y such that rho y1 y2 equal to dx1 x2, where y1 equal to phi x1, where y1 equal to phi x1 and y2 equal to phi x2. Note that rho is well defined. Now just phi, we write here phi 1 to infinity to 0 1 given by phi x equal to 1 by x, given by phi x equal to 1 by x. Then a new matrix on xy, a new matrix on 0 1 by setting rho xy equal to 1 by x minus 1 by y. That means phi x minus phi y. Okay, this one equal to 1 by x and 1 by y. Then rho is equivalent to the standard matrix on 0 1, the standard matrix on 0 1. Okay, then we talk about that phi if 1 by x1 not equal to 1 by x2 implies that x1 not equal to x2. So phi of x1 not equal to phi of x2 implies that x1 not equal to x2. Hence phi is all true. Okay, and this implies phi is 1 1, that is injective. And obviously there exists y belongs to 0 1 such that 1 by y belongs to 1 infinity. So phi of 1 by y equal to y. Then phi is onto, that is surjective. So phi is injective. Then so phi is bijective. 1 on 2, that means bijective. Then phi bijective, then we obviously done this one. This one is the equivalent to the standard metric. Okay, because these two are generate same topology. Okay, if we call this two are t and rho, d and rho, then this t and rho generate same topology on a set X. So this one are on this set 0 1 is equivalent to the standard topology on 0 1. Okay, then we say next problem. We'll erase these things. This one is the assumption. Now this called is transfer or transport the metric on x to y. Okay, now we see next problem on extend real line. Okay, that means we know about that. We consider the function phi r2 0 1 r2 minus 1 1 is given by phi x equal to x by 1 plus mod x, where then we have to show that first we have to show that phi be a bijection with the inverse psi y equal to y by 1 minus mod y. Okay, then for x1 by 1 plus x1 equal to x2 by 1 plus x2. Okay, here 1 by x1 equal to 1 by x2 implies that x1 equal to x2. Okay, not equal to. In previous problem we do some mistake because phi x1 and equal to phi x2 implies that x1 equal to x2. This implies phi is injective, and we discuss these things. This one is phi is well defined. Okay, here we discuss phi is well defined. in previous example some mistake, but here we discuss about this thing. So x2 1 plus x1, this implies x1 x1 x2 x2 x1 x2, this implies x1 equal to x2. So phi of x1 equal to phi of x2 implies that x1 equal to x2. Then phi is injective, then phi be injective. Now for x greater than 0, phi x equal to x by 1 plus x. Okay. Take y equal to this one. This implies that x equal to y plus xy. This implies that x minus xy equal to y. This implies that x equal to y by 1 minus y. Okay. So for x greater than 0, this one is forbidden. This implies phi inverse y equal to y by 1 minus y. Okay, then there exists so this one, then there exists, this one is next thing. So there exists y belongs to minus 1 1, okay, such that phi of y by 1 minus y equal to y. For y belongs to y 1 minus y, there exists y by 1 not greater than 0, x greater than 0, then y greater than 0. There exists y by 1 minus y belongs to R such that phi of y by 1 minus y equal to y. Then phi, and similar procedure for x equal to 0. For x equal to 0, phi 0 equal to 0, and for x less than 0, then we proceed another problem. For x less than 0, then for x less than 0, this one is minus, this one is minus, this one is plus, this one is plus, this one is plus, here minus 1 comma 0, then this one is happen here plus. Okay, so for x less than 0, this one happen. For x greater than 0, this one happen. So phi is on 2, then phi is 1 watt and phi is on 2, that means phi bijective, then phi bijective means phi inverse exists. Phi inverse exists means phi inverse of y equal to y by 1 minus mod y. Okay, then this one is done. So next we observe this phi extending to infinity, how this one is behave, or extending to minus infinity, how this one behave. Okay, so limit extending to infinity plus infinity, phi x equal to limit extending to plus infinity x by 1 plus mod x, then limit extending to plus infinity x by 1 plus x. This implies x tending to plus infinity 1 by 1 by x plus 1. This equal to 1. Since 1 by x tending to 0 as x tending to plus infinity. Okay, another one, limit x tending to minus infinity phi x equal to limit x tending to minus infinity x by 1 plus mod x. Then limit x tending to minus infinity x by 1 minus x. This equal to limit x tending to minus infinity 1 by 1 by x minus 1. This equal to minus 1. That means 1 by x tending to 0 as x tending to minus infinity. So we see about that as x tending to plus infinity limit phi x equal to 1 and x tending to minus infinity limit phi x equal to minus 1. Then we're going to further procedure. Y equal to plus 1 and minus 1 are the horizontal asymptotes of the graph phi. Now we discuss about R e equal to R union plus and minus infinity, and phi such that re2 minus 1 1 such that phi of infinity equal to 1, phi of minus infinity equal to minus 1, and phi of x such that x by 1 plus mod x. Okay, x belongs to R. Then this one phi is a bijection. Then phi is a bijection from R to minus 1 to 1. Okay, then we define DE on phi. Okay, we define one metric. This one is DE. Metric DE on RE equal to metric DE XY equal to D of phi x phi y. That implies that mod of phi x difference phi y. Thus this equal to D of xy. So DE is equivalent to DE is equivalent to D. Okay, then DE on RE is equivalent to D. Discuss DE equal to these things. Okay, now we not this one is discussed. Now we further consider another important problems of DE. That means this one is a DEB induced a matrix D1 on R which is equivalent to the standard matrix. That means the matrix DE induced a matrix D1 on R which is equivalent to the standard matrix. So that we have to show that DE on RE induces a matrix D1 on R which is equivalent to the standard matrix Okay, then we also discuss about these things. Then I erase this portion. We discuss these things. Phi A equal to phi A phi B equal to phi A minus phi A phi B, and we similarly sufficiently the open wall BD1 XR contains x minus r x plus r, okay, or contain x minus epsilon x plus epsilon for epsilon greater than 0. Let r be the minimum distance of phi x2 plus 1 and minus 1 such that r be the minimum distance from distance of phi x from plus 1 minus 1 such that minus 1 less than phi x minus r less than phi x plus r less than 1. Okay, then BD1 XR equal to psi phi x minus r comma psi phi x plus r, okay, is an open interval containing x, okay. Now AB be the D open wall such that AB be D open wall let AB be D open wall such that minus 1 less than phi A less than phi x minus r less than phi x plus r less than phi b less than 1. Then BD1 XR equal to phi of phi x minus r comma phi of phi x plus r subset of AB, okay. Then we see about that this this D1 DE is equivalent to D1. Okay, because D1 is open in the here, D1 also open in the BDX are subset of AB and AB be the D open ball. So D1 be open if and only if D is open. So D1 is equivalent to D. Okay, now we discuss these things just by taking or helping another example. So we see about that the metric on REDE induces some metric D1. Some metric D1 induces some metric D1 where phi AB equal to phi A phi B. And the open ball, this one is the this which is equivalent to the standard metric T, which is equivalent to the standard metric T. Okay, now we stop here.